Good morning. So today we are going to start with our previous chapter, that is chapter number 13, motion and time. So this is the second video for that.
Introduction. When an object changes its position with time, it is said to be in motion. Cars, buses, trains, aeroplanes, etc. are the objects that first come to our mind when we talk about motion. However, yet another object has motion. Try to recall a big grandfather clock. Do you remember seeing at the bottom of the clock a long stick with a ball attached?
What we can call this?
Pendulum.
Pendulum. So pendulum is also having some motions or not?
Yes.
What type of motion it is having? To and fro motion? To and fro? From one position to another? Again come back to that position. To and fro. This what type of motion is this? This is a oscillation.
That is a pendulum. It moves back and forth in harmony with the tick-tocks of the second hand. In this lesson, we discuss the simple pendulum, or simply the pendulum. Objectives. At the end of this lesson, you will be able to describe a simple pendulum, define oscillatory motion and time period of a simple pendulum, differentiate between uniform and non-uniform motion, clock distance time graph. Have you ever observed a wall clock? A simple wall clock or a wrist watch has a circular dial with 3 needles. The circular dial is divided into 12 equal parts, with each division representing 5 minutes. Observe the dial more closely and you will find that it has 60 smaller divisions in it. A single small division represents 1 minute. The longest needle, which moves the fastest, is known as the second hand. It completes 1 revolution in 1.
As all of you know, what is this? This is a watch. Or what is this? These are the hands of clock. Hands of clock. First hand and second hand. आपको पता है there is one big needle and one small needle. What it represents? It represents time. But how? While moving. After moving, it can represent the time. It is having some type of motion that we will discuss. How it is represented.
The smallest needle, which is also the slowest, is called the hour hand. It completes 1 revolution in 12 hours. The needle smaller than the second hand and longer than the hour hand is the minute hand. It moves slower than the second hand but faster than the hour hand. It completes 1 revolution in 1 hour. A simple pendulum consists of a small metallic ball suspended by a thread. The metallic ball is called the bob of the pendulum. The thread by which a bob is suspended is loose at the lower end and is fastened at the top to a stand. When the pendulum is not moving, it is said to be at rest. This position of rest is also known as the mean position or the equilibrium position of the pendulum. Suppose the bob of a simple pendulum is in equilibrium. If we now take it to one side, left or right, and release it, it begins to move to and fro. This to and fro motion of a simple pendulum.
So as I discussed earlier, that oscillation is performed. Oscillation means कि टू एंड फ्रो मोशन जो होता है कि आपने यहाँ से पुश किया वो आगे गया अगेन बैक कम बैक टू द इट्स ओन पोजीशन. दिस इज कॉल्ड ऑसिलेशन. व्हेन इट इज मूविंग फ्रॉम दिस पोजीशन टू दिस एंड कम बैक अगेन टू दिस पोजीशन, दिस इज कॉल्ड वन ऑसिलेशन. इसको क्या बोलते हैं? वन ऑसिलेशन कंप्लीट. One oscillation is completed from one place to another, then come back to that place. It is called one oscillation. And this motion, to and fro motion, is called oscillatory motion.
It's called the oscillatory motion. One full to and fro motion of the pendulum is called an oscillation. The pendulum completes 1 oscillation when its bob, starting from its equilibrium position O, moves to one extreme position A, from there to the other extreme position B, and then back to O. Alternatively, an oscillation can also be measured as the movement of the bob of a pendulum from one extreme position A to the other extreme position B and back to A. The time taken by the pendulum oscillation is
Now,
called.
there is a time period when how much time is going to be taken by the pendulum to complete one oscillation. Time taken by the pendulum to complete one oscillation from here to here, then again come back to here, is called time period. That is the period of time in which that bob is moving from one position to another and come back to the original position. Okay.
Its time period. You can compute it with the help of this simple exercise. Take a simple pendulum. Let it come to rest. Identify the equilibrium position O on the ground below. Now take the bob to one extreme position A and identify it on the ground below. Start a stopwatch and release the bob at the same time. When the bob comes back to the extreme position A, note the time on the stopwatch. Repeat the activity.
How much is the time period? 5 seconds. 5.09 seconds. Okay. This is the time period for one oscillation. For one oscillation, time period is 5 seconds.
This time, start from the equilibrium position O. Note the time taken by the pendulum to complete the one complete oscillation from O to A to B, B to O. The time so recorded is the time period of simple pendulum. Motion can be classified as uniform or non-uniform depending on the speed.
We are having two types of motion: uniform motion, non-uniform motion. As name describe, uniform मतलब कुछ straight motions होंगे, non-uniform जो straight नहीं होंगे, जो थोड़े diverted होंगे. Okay, let's see.
Speed of an object. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. A bus, for example, moves at varying speeds over.
जब हम कार या बस या कोई भी गाड़ी राइड करते हैं, then what we did, चेंज करते रहते स्पीड को, कभी 10 किलोमीटर पर आवर, कभी 20 किलोमीटर. तो यूनिफॉर्म है वो नहीं है. यूनिफॉर्म क्या है? जब एक स्पीड आप पकड़ लेते हो, जैसे कि आप हाईवे पे ड्राइव कर रहे हो एंड यू स्टक सम स्पीड्स लाइक 50-60 किलोमीटर पर आवर, यू आर रनिंग योर कार, then it is called a uniform, a straight motion. Or otherwise, when the fluctuation in the speed, then it is called non-uniform motion.
Varying stretches on its long route, hence its motion is non-uniform. If an object moves along a straight line at a constant speed, then it is said to be in uniform motion. A car, for example, may maintain the same speed when it covers a short distance. Motion of objects can be presented in pictorial form with the help of distance-time graph. For this purpose, first draw a horizontal line to represent the x-axis and a vertical line to represent the y-axis and mark them as OX and OY. Measure time along the x-axis and distance along the y-axis. Mark values for the time and the distance on the respective.
Here, this is our representation in the graph, representation in graphical way. Now, we are having distance and time. So, we are going to plot the graph between the distance and time. Time is given to us, that is 8:30 to 9, 9 to 9:30, 10, then 10:30 and 11 o'clock. Okay, distance 10, 20, 30, 40, these are the kilometers. These are in kilometers. Okay, now we have to plot the graph according to the speed of that particular vehicle. जो हमें given होगी उसके according हमें plot करना होगा ग्राफ. अगर suppose करो 10 किलोमीटर डिस्टेंस कवर करता है up to 9 o'clock, okay, again same 20 किलोमीटर डिस्टेंस कवर करता है up to 9:30, तो उसकी एक स्पीड क्या है? कांस्टेंट है, मतलब यूनिफॉर्म मोशन में जा रहा है, मतलब एक पर्टिकुलर इंटरवल ऑफ टाइम में वो इतने किलोमीटर्स कवर कर रहा है. अगर 10 किलोमीटर्स 10 किलोमीटर्स कवर करता है इन हाउ मच आवर्स? हाफ एन आवर. Again in half an hour, how much it covers? Again 10 kilometers it covered. How? 10 20 minus 10 is 10. 20 minus 10 is 10. Again after 20 पे वो आया, 20 किलोमीटर पे आया, फिर उसने अपनी कार स्टार्ट की और फिर हाफ एन आवर में उसने 30 किलोमीटर रीच किया. दैट मीन्स 30 minus 20 is 10. मतलब डिफरेंस कितना आ रहा है? 10 किलोमीटर का डिफरेंस आ रहा है. 10 किलोमीटर वो कितने आवर्स में कंप्लीट कर रहा है? हाफ एन आवर में. और उसकी वो स्पीड उसने कांस्टेंट रखी है. दैट्स व्हाई वी कॉल इट एज अ यूनिफॉर्म मोशन. Okay.
Axis. Now plot the points on the graph paper, each each pointer presenting a specific combination of distance and time values. Join all the points on the graph to get a linear distance time graph, which shows that the vehicle is moving at a constant speed. From this graph, we can calculate the distance covered.
Now you can see how much distance is covered by vehicle at 10:10 a.m. 10:30 is there. 10:10 a.m. में कितना डिस्टेंस कवर किया होगा उसने? अप टू 10:30 उसने कवर किया है 40 किलोमीटर. 40 किलोमीटर. ओके. 10:10 पे कितना हुआ होगा? बिकॉज डिफरेंस कितना है 10 to 10:30. तो डेट मीन्स वी आर हैविंग 30 इन बिटवीन. 15 के पहले क्या आएगा अपना 10 आएगा. 15 से पहले 15 पे उसने कितना कवर किया हुआ? नियर अबाउट 30 to 40 है तो कितना हुआ होगा? 35 के आसपास, 35 किलोमीटर के आसपास. बट उससे भी थोड़ा सा पहले है तो उसका नियर अबाउट 26 या 27 सॉरी 32 या 33 किलोमीटर्स होगा. 32.5 या 33.5 whatever the answer we are having. See.
By vehicle at a particular mode, we can calculate the time at a particular distance from the starting point. In the same way, we can calculate speed also. Summary. Let us summarize what we have learned. To and fro motion of simple pendulum is called oscillatory motion. Time taken by single pendulum to complete one oscillation is called time period of simple pendulum. If an object moves along a straight line at a constant speed, its motion is said to be uniform. If an object moves along a straight line at a speed that keeps changing, its motion is said to be non-uniform. Motion of objects can be presented in pictorial form by their distance time graph. The distance time graph for the motion of an object moving with constant speed is a straight line.
So your chapter is completed. All of you come to know all these points. Do you have any doubt in these points? You know what is pendulum, you know what is oscillation, you know what is oscillatory motion, then you know what is distance time graph, okay, what is uniform and non-uniform motion, then how we can find out the distance speed with the help of distance time graph, how we can find out the motion of the object with the help of distance time graph. All the points are clear? All the points are clear? Yes or no?
Yes, ma'am.
Okay.